What I'm making is a conductivity meter. Looks like this. When dipped into a solution, it can register the conductivity by how brightly the bulb glows. This is Southern California tap water, which is fairly conductive. For this project, I'm using a ceramic light socket. This is a plumbing piece. It's called a tail piece. 2 pieces of 12 gauge copper wire. This is a cheapo extension cord. This is a Marriott hotel card key. Some scissors, cordless drill, some wire cutters, and wire nuts, and a hot glue gun. You may be able to see inside how it's constructed. There are two copper wires that are disconnected, and if there's a conductive solution between these 2 copper wires, the light bulb will go on. If I were to touch these, I would get shocked. I'm first going to drill a hole here for the electrical cord to go in. I'm using a rat tail file to smooth this out a little bit. There's my 5/16 inch hole in the plastic. So you need to cut the extension cord. This is easy to do with wire cutters. Goal is to have, here's the part that plugs into a socket, and then the other end is just going to be wires that you can connect. I've separated it here. That's easy to do. It's got this groove down the middle, and you can just pull on it. A little snip with wire cutters will help it get started, and then you can just pull them apart. So now I'm feeding the cut ends through the 5/16 inch hole here, and it's snug, but they go through easily. One of the copper wires will attach directly to the socket, and for that I'll put a crimp in it with my pliers, bend it, okay, and then just use a screwdriver to attach that down. So that's a secure electrical connection there. So you can imagine now the socket being on top, and the copper wire, this one's too long so I'll have to cut it, but it goes straight through the pipe. I've stripped the ends of the extension cord wires. They're also made of copper. Now I'll connect one of the wires from the extension cord onto the second screw terminal here. Okay, that looks pretty good there. Now this part, it gets tricky. This is where I need to connect this to the second copper wire. I'll connect these two together, and then I'll have to loop this around so that I have 2 parallel leads going through the tube. Okay, so here's my first guess. This is about, roughly an inch or so, and this is where I'll twist these 2 together and add a wire nut. Okay, so I'm trying to twist these together. It's a little difficult because this is stranded and the other one is a solid copper. But here we go. Now I'll put a wire nut here. I'll need to tug on it to see whether they're securely fastened. Tug, 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 feels good. Tug, 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 feels good. Okay, so now I have 2 leads, and I need to get them into the tube in a way that they don't touch each other. Now I'm going to use the card here and cut a segment out of it, almost a rectangle, that will fit inside the pipe, but fairly snugly. So I have to trim this a little bit. You can see I've trimmed it. It'll fit inside now snugly. You can see it's all floppy here, but the card will make it so it's less floppy. I'm using a drill bit that's the same diameter as the copper wire. It's 3/32 inch. Just drilling 2 holes in the card. There's 2 holes drilled on the edges. Now I'll try to slide this onto the copper wires. There we go. There we go. Okay, so that'll keep them spaced apart from each other. So I put one of those pieces of cards here, and here's the second one, similarly constructed. This one has tighter holes. So this one I like better, actually. You can see it takes me some force to move this, which is good. But this one up here is also helpful as a spacer. You can see that these wires can't touch each other up there. Can't touch each other here. So I've got parallel lines that can go in the tube. Since this one is loose, I'll put just a dab of hot glue there to keep it in place. So here I'm adding a dab of hot glue to keep this spacer in place. So now you can see the construction. 2 parallel lines, spacer, 2 spacers. This one can still move. I didn't glue it because I've drilled 5 64th inch holes. Here's the pipe. You can see, I think, that the wires are too long, so I'll trim them. Okay, and then I'll move this slider up just a wee bit. There we go. Okay. Whatever distance you have here is the minimum depth of liquid needed to get a reading. Now I'm going to try to put this inside. So this wire is pretty long right now. I'm pulling it back. And I want to get the Marriott cards so that they look like so. Maybe the other side is better. Probably better. Okay, like that. Like that. Stuff the wire nut inside. And now I have to pull and hope that it all goes. So I'm pulling. See, I've got a loop here. I've got to get that loop out without breaking anything. Okay, delicately now. Alright, you can see everything stuffed in there nicely. And I can push this down. And there are my 2 wires on the bottom. Separated nicely. This should be good to go. So I'll glue this at the end to make it so that it can't go anywhere. But first I want to test it. The light bulb I'm using is a 25 watt decorative bulb with a clearly visible filament, clear glass bulb. So here I plugged it in, the light is not on, that's a good sign. If I short the 2 leads, short the 2 wires with the conductor, the light does go on. so that's a good sign. As I immerse this in the water, it's a very dim glow, which is not as bright as I want it to be. I'm going to cut some of this white tubing off so that the wires are closer to the bottom, and that will mean more of the wire is immersed. That's the only part that matters. You want about 3/4 inches between the end of the wire and the end of the tube. So this one's actually only about 1/2 inch. So I'm going to trim it with wire cutters. Just cut a wee bit off there. That's better. Probably good enough. This one's 3/4 inch, yeah. Okay, so that's what it looks like on the bottom. So things are fairly stiff, and this really doesn't fall out. But I'm going to hot glue it down. You can also use some kind of caulking adhesive to cement this in place. Okay, so I'm just going to put some globs here and a wee bit here around the rim. Okay, good. Okay, so now that feels secure. There's the wires on the bottom. This is good. I'm going to try it out. Here's the moment of truth. Light is not on. Good sign. I'm dipping it into tap water, and there's a nice glow. There's a nice glow right there. So this is perfect, just the way I wanted it to be. Total cost is about $10. Very durable. I've used the same one for at least 15 years and no problems, no maintenance required. The only maintenance I do is I rinse the electrodes with tap water when I'm done with my demonstrations. I've put this in the hands of students, no problem. You do have to warn them, don't stick your fingers in there, but I don't think they'll be prone to do that. If you're not getting any light, it may be because your water level is too low. You can see that if the water level is low, then it won't reach the electrodes. Now I'll show you if you add something that makes it more conductive, then the light will get much brighter. There you can see it, a nice bright light. So this is really good for demonstrations for a classroom because this is a big enough device people can see it from 30-40 feet away. I'm starting with a plastic piece that's for plumbing. It's called a tail piece. 1.5 inch. This one's 16 inches long, which is actually long enough to make 2 conductivity devices. It's plastic, so it's easy to cut with a saw. That's what it looks like when it's cut. This is about 8 inches. The edge here is kind of rough, so I'll just smooth it with a file. For my wire, I'm using 12 gauge copper wire. This is what you use in your house for electrical wiring. You can probably also get 12 gauge wire from Flynn or a hardware supply store.